All right, let's learn about rotations. Rotations are where you turn or you spin a pre-image to make a new image. When we talk about rotations on a coordinate plane, the first thing you should know is that if it says graph the rotation and it doesn't say whether it wants us to turn it clockwise or to turn it counterclockwise, the default in geometry is that they want us to go counterclockwise, which is probably because the quadrants are labeled 1, then 2, then 3, then 4. So that'll come up a lot when you study trigonometry more too, that we usually rotate this way. So when we rotate, we're going to just start by rotating this thing 90 degrees. And I would expect that if you rotate something 90 degrees, a quadrant 1 pre-image should wind up in quadrant 2. Now where those coordinates are going to go, maybe you're good at eyeballing that, but I'm going to show you a nice trick of how to get those coordinates exactly. The first thing I want you to do is put your pencil right at the origin, because the origin is going to be our pivoting point. Now if we wanted to turn this, and I'm expecting that to show up in quadrant 2, hold down your pivot point and actually turn your paper so that if this was the new up and down axis and this was the new side to side axis, does that look like it would be in quadrant 2 if this paper was facing the right way? So now if we're picturing that this is in quadrant 2, you can see that point A is back at -2, +1. And so I'm going to write that down in this box. A prime is at -2, +1. When we turn back our paper, that'll make a little more sense. But let's continue doing that for point B. Point B, when I'm looking at it this way, is at -4, +4. And point C is at -1, +3. So I'm going to turn my paper back now and I'm going to plot those points the way I was seeing them after a rotation. So -2, +1. That's where I was seeing that A prime. B prime at -4, +4. And C prime at -1, 3. And so that gives me a good picture of what I was seeing when I had my paper turned. And so that's supposed to look like what this would look like if I pivoted around the origin 90 degrees. Now if you look carefully, if you connected to point A and to point A prime, you would expect to see a nice 90-degree angle right in there, and that would work same for C to C prime and B to B prime, but that's just an easy way on the coordinate axis to get those new points. Let's try the 180. So 180. So you can just ignore all this blue now. I'm going to switch colors even. We're going to spin this thing 180 degrees, which basically means spin it all the way upside down. A quadrant 1, you would expect to see it all the way upside down. Now it sort of looks like it's in quadrant 3. That would be my 180 degrees brings me to quadrant 3. So now if I'm looking at this as if it were in quadrant 3, I'm thinking, okay, this would be -1, -2. -1, -2. B prime. Looks like it's at -4, -4. And C prime, -3, -1. Once you get all of those written, turn back to your original pre-image and let's graph those. So we're going to graph A prime at -1, -2. B prime. And C prime. This would be a lot harder to do if we weren't turning in intervals of 90, 90, 180, 270. But since the X and Y axis are at 90-degree angles, it makes this pretty easy. Alright, the last one is our 270. So 270 is a 90 plus a 90 plus a 90, so that's going to go 1, 2, you're going to expect 3 quadrants. You could also think of it as a 90-degree turn clockwise, right? But it does say 270, so let's pivot from the origin, that's our center of rotation, and we're going to turn this until our pre-image looks like it's in the 4th quadrant. So here would be 90, 180, 270, and that's where we want to be. We want a 4th quadrant image. So same thing that we've done before, we're going to pretend that's the 4th quadrant now. Find our A prime. The book has these fancy rules that if you wanted to memorize a rule for how to find each of those points each time you could. I really don't see the point in that when there's this nice easy trick of just spinning your paper. Alright, A prime at 2, negative 1. Did you notice that all of these image triangles are congruent to the original? And what does that mean? It means that a rotation is, and what's the word? Isometry. Rotations are isometries because the new image is congruent to the original. Alright, flip to the back side. You look like you're ready for a challenge. We're going to try rotating this rhombus around this point, and we aren't stuck with 90s or 180s. We can do whatever we want as long as we bring in our protractor. So let's say we wanted to do a 60-degree rotation. And if I just say 60, which way does that mean I want you to go? Counterclockwise. In math, that's kind of the default, is going that way through the quadrants. Alright, so how are we going to manage this? Probably the easiest way is to go point by point. So let's pick a point to start with. Maybe we want to start with this point right here. I think we should even label it point A. And so what I'm going to do is I'm going to sort of just connect this to my center point so I can picture that rotating. So if I wanted that line to rotate 60 degrees, I would sort of picture it coming over to here. Some people might want to use a compass to picture that rotation. This might help you just visualize it even if you don't use one. But point A, if we rotate that, is going to rotate somewhere over here. I think I moved it a little bit. Somewhere over here. And to tell how far over there we want to rotate it, that's where we're going to use our protractor. So remember, you want to use your 0 lined up with point A. And I promised you a 60-degree rotation, so let's put a mark out at 0, 10, 20, 30, 40, 50, 60. So I know that A prime should wind up on this line. And A prime should be right at that intersection point. If you're not going to use a compass, you can definitely just use a ruler to see how far out that should be. So if point A was, what does that look like, 4.7, 4.8, then A prime should also be at 4.7 or 4.8. Looks good. And I think labeling them is going to help because we're going to have so many lines and arcs and weird things on here when we're done that you'll want labels. Let's do B. And you know, As long as we're doing B, I feel like we could do this point too. If we call that one C, let's call this D. I think we can do B and D at the same time because they're sort of lined up. So wherever B and D go, they'll kind of move together. And so if we can picture those going 60 degrees as well, again, we'll line up our protractor at 0 with the pre-image, and we're going to rotate 0, 10, 20, 30, 40, 50, 60. And so here's where I would expect this line to be. So this line rotates 60 degrees to this line, and now we just have to find out where D would wind up and where B would wind up. Again, if you wanted to use a compass, that's actually a pretty easy way of doing it, so you don't have to measure. Right? If you just open the compass and imagine B traveling over here, and picture D traveling over here, you can sort of picture that spin then. But you can measure it too. B looks about 7, huh? 7. There it is. And D, 2.5. And our last one is C. So I like to connect the center of rotation to the point, and then I want to picture this line. See how I said there's so many lines here to keep track of, but if you just stay focused on which point you're on, we're working on C. So we're going to take point C, 60 degrees around the circle. Point C is going to be somewhere right there. I feel like it's going to be right at that intersection, because it looks like point C is the same distance as point A was. What does it look like? 4.7, 4.8? So we'll rotate it. 4.7, yep. Right about here. So if we connect, and this is always you'll be able to tell if you screwed anything up here when you connect them, because if this doesn't look congruent to my original pre-image, something went wrong. So all these angles should be congruent. All these lengths should be congruent, because we have an isometry. So that was a little more complicated than the coordinate way, but equally fun.